Now, is that categorical or quantitative? Remember, quantitative is a number that can be averaged, right? Now, looking at the data sets, what is the smallest number of pairs of shoes the students owned based on this distributions? What do you get? 2? And which display did you use to figure that out?
I used the stem plot.
The stem plot, yeah. Why? Why'd you use the stem plot?
Because you can't really tell from the other one.
It's not as clear, is it? You can't tell from the histogram for sure. Dot plot you can estimate, but it's not always as precise. But stem plot's pretty clear, right? Okay, so 2 is the lowest. What's the highest number of pairs of shoes?
34.
34 is the highest. All right. So the mean of the data is 8.63, but the median is 7. What's the difference between mean and median?
I have no idea.
Mean is the average.
For real, you don't?
No.
Mean is the average. Y'all know how to find average. Do you remember averages? How do you average something? Add them up and divide by 2. Exactly. That's all average is. We just say mean instead of average. Right? Now, median is a location term. Like if you listed all the data points from least to greatest, the median is the middle. Okay? Think of it like the median in the freeway, right? Cement, right? It's the middle. It doesn't really move. The mean is what we call non-resistant. It does move. Like if you throw a really high data point, like if I throw someone in there with 100 pair of shoes, is that going to change the average? Right? A lot, isn't it? But if it's just one more data point, it may not change the median that much if you line them up and find the middle number. Okay? So because of that, median is considered resistant to outliers, mean is non-resistant. And don't let me forget to show you a meme about this before you leave. It's one of my faves. All right, so that being said, which one do you think is the more appropriate measure of center? Mean or median? When we say center, we're talking like typical. What's the typical number of pairs of shoes?
Median.
Okay, defend yourselves, mean people. What do you say?
Median because
Defend it. Okay, why? Why do you think the 8.63 is a better estimate of what the typical number of pairs of shoes is?
Because it includes all the shoes. And so why? And like the median, just like the precise middle, it doesn't like really include every single shoe.
Okay, you're saying median?
median because it's a full number. You can't have 8.63 pairs of shoes.
But I don't know if you remember finding median back in the day, but it can be a decimal. Medians can be decimal. This one's not. Okay, so a little sidebar. And stats, when we do calculations like means or medians and they come out decimals, it's okay. There will be a time when we have to round to whole numbers, but that doesn't mean we round these. So what do you think, Alexa?
I said median because 34 and 22 are outliers.
You think 34 and 22 are outliers?
And they're throwing off the average.
And they're throwing off the average? So if you're saying that if we take out 22 and 34, what do you think the average would be out of the day set? Just ballpark here. Anybody want to guess? I don't know. I don't know the answer. What do you think? You do?
No.
Please enlighten us.
I know the answer.
But is it closer to 8 or closer to 7? What do you think? 9?
I say, why would you choose that?
So I'm taking off this data point, taking off this, and then averaging all of these. What would the typical value be then?
Yeah, it's 7.
Maybe even lower, right? 6 or 7, maybe? So, anyone else have an argument? What do you think?
Yeah, I was just gonna say mean because it's saying the center, which is the typical, or something. I forgot the right word for it, but it was like typical something.
Yes.
So the mean is like the typical, right? Because it's It's like the average.
We use the word typical to say center, and it could be mean, it could be median. I know, it's a gray subject. I know. It's okay. It's okay. Don't hate. Don't hate. So, here's the rule of thumb. So glad you asked. How do you know which one to use, right? It's all about the shape. Okay, in the videos talked about shape, right? What shape is this guy?
Skewed right.
Skewed right. How do you know? The tail of it falls on the right, doesn't it? Okay, so it is skewing to the right. Anytime your data is skewed, we don't want to rely on the mean, because the mean will just go towards wherever the tail of the data is. So since the tail of the data is getting higher and higher, the mean is going to be higher than the median. Does that make sense?
Mm-hmm.
So if I take these outliers out, that average is going to come closer down here, isn't it? If my data was symmetrical in shape, approximately symmetrical, then your mean and your median would be almost identical. So it wouldn't matter, honestly. But anytime it's skewed, that means there's probably some outliers that are messing up the true average, and we don't want to rely on that. So the one that's a better appropriate measure of center would be median. Okay, so we would say median because the distribution is right skewed. Okay. All right, number 4. How many students owned 0 to 4 pairs of shoes based on that histogram? Everybody agree? 8? 8 students. Then we know that because it goes up to the frequency of 8. So notice on the histogram, your y-axis is not percents in this case. It's frequencies, counts. How many people in each bin? Okay? And then it says label the bar on the histogram that 5 pairs falls into. Which bar does the 5 pair fall into? The first, the second, the third?
Second.
Okay, so 5 pairs falls in here. So make sure you're reading it carefully, all right? Questions about that? Okay. Now to describe the distribution and the number of pairs of shoes. First thing we do is describe the shape. What shape did you just tell me it was? Right skewed. Outliers. Do we have any data points that we think might be outliers?
34, 22.
Maybe 22, 34? We will come to a point later in the chapter where we actually calculate and define is it an outlier or not. But right now we're just eyeballing and estimating, okay, looking for gaps in the data. Center, what did we say our center was? 7. We're using median for center, and it's going to be 7 pairs. And then spread. Spread is a measure of how variable is the data, like how spread out is it. Your most familiar measure of spread to this point in your educational career is good old range. Do you remember range from middle school? How did you calculate range? Do you remember?
You got the top and bottom number.
Okay, so we take the max minus the min. So in this case, it'd be 34 minus 2. So this data set has a range of 32, not 2. 32. Easy enough, right? We won't use that value much in here because it's a middle school thing and we are AP stats, right? We will get more sophisticated. We're not going to do middle school. No. Now, notice something. Look at this little acronym. SOCS. What does that spell? SOCS. So why do I have SOCS? I'm not a total nerd. There's a point to this. SOCS. There it is, right? SOCS. So it's a reminder. Anytime we describe a distribution, we have to do shape, outlier, center, spread. SOCS is always part of it. So You have to address each one of those components to get full credit on a description. It might require 2 sentences, it might require 4. It just depends on what you got to talk about. And if we're comparing 2, okay? Now, the other thing that you have to include to get full credit is context. Context, context, context. I need to be able to not look at the graph or the display and look only at your paragraph and be able to read it and understand what was the data about. If you just give me a list and say shape, right, skewed, outliers, maybe, center, 7, that tells me nothing about the data, does it? I don't have any idea what the data represents. So I need to be able to read your paragraph and know what the data means. Okay? That's the generic. That's not how your answers will look in the long run, but this is just the quick cursory overview. All right? It is a checklist, though, however. When you do questions like this on a quiz or a test, you will see me in the margin do SOCS, and I check off as I read your description. Does it have every component? Because they will dock you if you miss it. Context is one of those, okay? So, questions about that? Turn the page. All right, so looking here. First thing we talk about here is shapes. In the video, we talked about some of this. Unimodal means it has 1 peak to it, right? So what would 2 peaks mean? Bimodal. All right, so looking this way, what did we say this shape would be? Skewed right. The tail's on the right. So it's location of the tail, right? And then symmetric is when it's pretty balanced to the center. Oops. Why'd you do that for? One moment. So then this one would be skewed left, right? Correct, I should say. Alrighty, so describing distributions. Here it is. Address SOCS and always put context, right? Shape, what are our choices here? What do we say? Papers. Nobody? Okay, all the ones that we needed are on other parts, right? See number 2 right there. There's no need to rewrite that. All right, all our shape options are right there. Outliers, okay? Data far, I should say, how do I phrase this? Data far from other points. For now. Data that's far from other points of data. Gaps, right? Center, we talked about this. You can use mean or you can use median. When do we use mean? Do you remember? Good. We only use mean with symmetrical distributions, and then we use median for skewed distributions. Or outliers. You could say outliers because that's what's going to make it skewed. But now spread is what it sounds like, how spread out the data is. And in stats, we sometimes call that variability. How variable is the data? Does So if you have a lot of possible options for the data set, then it's high variability. But if there's not too many, then it's a low variability. You'll hear that a lot. All done? Okay, now this thing over here on the side, it says cushion your answers with ly words. Okay? Remember you're writing in like a paragraph form when you do descriptions? So when I say ly words, I mean like approximately. Spelling is hard. Approximately, slightly. What's some other adverbs we can use? Strongly. Okay? Things like that, because here's the kicker. It's never going to be perfect. Perfectly right skewed, perfectly symmetric, it's never ever going to happen. It's all going to be approximate or slightly. If you want to argue something skewed and you're not really sure, throw in a slightly. Okay? It gives you some buffer. It's slightly skewed, but then argue your point. Why do you think it's slightly skewed? Because these points may be outliers. All right? So this will come into play, and we'll break this down even more as we get into comparing distributions. All right? All right, so now I want you to try this on this application problem. University of Michigan in 1997 had a perfect season. The dot plot shows the number of points scored by the team in 12 games that season. So there it is. So I want you to use that dot plot to create yourself a stem plot. Describe the shape, any potential outliers, and why do you think so? Which measure of center is most appropriate, and why do you think so? All right, I'm going to give you a little bit of time to work on that. And then we'll come back together and check your answers. Okie doke. Talk amongst yourselves. This point is to talk to each other on this.
I watched the vlog. I watched his first ever live stream. I watched him go, and he was like, oh, we're Goku. He started voting after that too.
I was thinking since I'm joining stuff.
Whoa. Huh? Well, join you. I'm trying to figure out my iPad here. My what? My Apple TV? You're gonna hack it?
I can't see it. It's free.
Oh, yeah.
I could just walk over there.
You could, but that would require you getting up and walking.
Wow.
Highly unlikely.
Wow. That was good.
I go way back. Sit down. It's too much work. Let's just call it what it is. It's too much work for you.
I'll wait for you to unfreeze it.
I know you will. I know how that goes. Yes, ma'am.
I was wondering, would you call this to be uniform? Because there's just one. That's
I think it's easier to see here, looking at the shape.
Oh, okay.
You can do it both ways. You can use either one.
So symmetrical.
I think it's approximately symmetrical. Yeah. Yeah. All right, you ready to check it? Check yourselves. All right. Unfreeze. Okay.
I forgot the key.
Yeah, what did you forget? Key, okay. That's how I did my stem plot. Did you put a key on yours?
Yes.
You gotta have a key. It's incomplete, otherwise I can't tell what the data represents, right?
I didn't do a key.
Uh-oh. Fix it now. It don't count right now, but it will count later. Put a key with it.
You said it was symmetric?
I said it's approximately symmetric. It's not perfect.
I thought it was skewed less.
Not really, because there's not like other data over here. Oh, skewing left?
Yeah.
They're like slightly.
No, you can put that in the thing, it's approximately.
Well, if you take out 37, it's 38.
I think it's closer to approximately symmetric than being skewed.
Yeah.
Skewed is really going to come into play when you have some gaps in the data, and you got to extend that tail to capture those outliers.
Okay.
Does that help? Don't be afraid to say approximately. It is our best friend in stats because nothing is perfect. Okay? That's why I said approximately symmetric. Okay, outliers. Right now, I said maybe 14, maybe 36, maybe even 34 and 38. We don't know for sure because we haven't done the calculation. I haven't taught you how to build the fences yet. But right now, we're just eyeballing where are those gaps in the data. You okay with that? And then letter D. What measure of center is appropriate to describe this distribution? Well, it depends on what shape you said, right? Okay, fair enough. If you said skewed, what measure of center did you pick? Median, which would be correct. If you said it was skewed. If it's symmetric, we would use mean. Got it? All right, you ready for my picture? Oh shoot, what are you gonna do? Let me pull up my memes for you. Oh, you don't get to look. If you're gonna be sauce like that.
I will.
I swear I uploaded them. Did they go? Did it not?
It's very obvious.
Actually, how do you mix them up? So when they see you like here, they don't be like.
Okay, fine. We'll go old school. I'm just switching screens. It's okay, peeps. It's not pulling up on my deal, pickle, deal. All right, here we go. Do you get it? Do you get it?
Yeah.
Do you get it?
You're so funny.
I know, right? I know. Stats is so much fun, right? Fix your face. Yes, it is. The mean chases the tail, right? That's what we say?
Yeah.
The tail of the data. Let's be clear. The tail of the data.
Yeah.
But I didn't say anything else. I'm just saying the mean chases the tail. The median stays put. Yeah? Yeah? Got it? Lock it in?
Well, locked in.
Locked in? I knew it would work. I knew it would. So, there you go. I forgot to show third period, but oh well. Maybe tomorrow. LOL for them. Okay. So the rest of the period, we've done our simulation. You have time to do a few things. Sign your AP contract if that's you. AP Classroom. And or watch your video or start your video for tomorrow. I am going to pass back your quizzes so you can see them. All right. And ask questions. So much homework is not for me because
Oh yeah, because you're behind. Quite a bit. That shouldn't be that much. You should be like only 3 days behind. Hey guys. He's like 52 of
Of course you are.
The notes? No.
Maybe I haven't told you.